Hello, good morning, good afternoon, or maybe good evening, everyone. This is Umar Amin from London, and I am going to present data analysis on Airline from Chicago, Illinois Airport. In this presentation, we are going to address three questions in two sections. The first section is on the profitability of the routes, and the second section is on the investment decision for new route of Chicago to Atlanta. If we go to slide number 2, over here we can see a summary of data analysis methodology which we have employed for finding the most profitable and the least profitable route. We have a limitation in data given to us as it does not help to calculate profitability directly. Hence, we have employed an indirect approach by reviewing factors on the revenue side and on the cost side. And the two of these factors, seats booked per flight, the number of flights on a route, are common on both revenue and on the cost. So we believe they do not have an impact on the profitability. However, the factor of average ticket price on revenue side and the factors of fuel cost per mile, seat, aircraft type, and route distance on the cost side will help us in finding the most profitable and least profitable route. If we go to slide number 3, and the first factor on the revenue side, average ticket price, we can see over here it has a good range from $122 to $5,146, which is for DC Airport, Washington. Perhaps we can also see that this is an outlier. We can say that maybe the DCA is the most profitable route, and the route with $122 price to Detroit is the least profitable. But we cannot say without analyzing the remaining factors. So if we go into slide number 4, over here the next two factors on the cost side, aircraft type and the fuel cost per mile, are analyzed. The top table shows us the three aircrafts are used: A319, B320, and A319, A320, and B737. Perhaps A319 is the most fuel efficient aircraft. However, all these aircrafts are used on all the routes. So this tells us that the type of aircraft type cannot be a determinant of the profitability of the routes. We can see the bottom graph, which is average fuel cost per mile by route, and over here we can see the average fuel cost for all 24 routes is almost same, 3.5, around $3.5 per mile. So this is also not a significant contributor to determine the profitability of the route. If we go to next slide, slide number 5, here we can see the analysis on the route distance, which has a good range from 200 miles to 1600 miles. San Francisco route from Chicago to San Francisco is the longest with 1600 miles, and route from Chicago to Detroit is shortest with 200 miles. We can say that maybe that route to Detroit is most profitable, and the route to San Francisco is least profitable since it is the longest. However, we have to see this factor along with the average ticket price. So far what we can conclude that the factors of average ticket price and the route distance, they are the key determinants in finding the most profitable and the least profitable route. So if we go to slide number 7, where we have considered these two factors together, we can see the graph on the top, there is a peak where the average ticket price is highest for the route to DC Washington Airport, and there's a dip on Charlotte Airport. This give us a thought or our idea about an interesting metrics, which is like average ticket price per mile, means how the average ticket price is doing compared to the route distance. This tells us that the route to DC Airport in Washington has a factor of 8.33 dollars per mile, and the route to Charlotte has a factor of 0.18 dollar per mile. So based on this factor, the route to DC is the most profitable, and the route to Charlotte is the least profitable. So what is happening overall on the most profitable and least profitable and all other routes? So here is a graph on slide number 8. plotting the revenues and the count of flight or the number of flights on the each route. We can see over here there is some margin to increase the traffic on the most profitable route to Washington, and similarly the ticket price for Charlotte can be increased considering the price elasticity of demand. Also, we recommend that any route which has with a factor of average ticket price per mile with that is less than $0.3 per mile has to be reviewed to see if the ticket price can be increased considering the route distance. So going to our next section, which will look into 4 techniques of NPV: scenario analysis, sensitivity analysis, and simulation to answer the question if we should add a route from Chicago to Atlanta. The slide number 9 is showing the 2 techniques of net present value, also called NPV, and scenario analysis. We can see the top left graph showing the cash flows for 5 years, and here the NPV is positive approximately $115,000 with a discount rate of 10% for 5 years, and the IRR is strong, 27%. Similarly, scenario analysis has been performed for 3 scenarios: the baseline scenario, high growth with margin impact, and low growth with margin impact. We have shown only the results for the last year of 2021, gross profit and operating income, and they are in a good range. They are positive and in a good range, which is also giving us a positive answer or a result. Without going into these details, we can go to the next techniques, which is on slide number 10, showing the sensitivity analysis. Over here, we are analyzing the profit per flight, considering passengers demand and the fuel cost per mile. What we can see over here, if the fuel cost is higher than $1.44, then profit can diminish. Also, we should consider over here that the maximum number of passengers or demand of passengers that can be accommodated in a flight is 185. So fuel price higher than $1.44 is a significant risk. We can consider these 2 factors in our simulation technique. So if we go into slide number 11, over here we can see the 3 tables. The top table is giving us a summary of this route. The length of this route is 510 miles, and the annual number of flights planned are 385. So the total mileage annually shall be 196,350. The minimum cost of fuel is foreseen as $1.30. The maximum cost is $1.50, and we have considered a revenue per passenger of $150. With the available details on the passenger demand, there is a probability for 135, 150, 175, and 185. We can see in the bottom left table, and on the bottom right table we can see the result that the probability of the profit is very, very low. So the decision is this route of Chicago to Atlanta should not be added, probably because of risk of the fuel cost price and the passenger demand. So this is the end of our presentation. Thank you for your time and thanks for your feedback.